Welcome back. Today is all just review for the tests that we'll be having over the break. I'm planning on giving you guys the test. I'm finished writing it. I'm just kind of compiling the different forms together right now, so I should be done by around 9 or 10 tonight. So you'll see the tests up on WeChat. I will also post to course sites later tonight, so around 11 to midnight-ish, assuming nothing goes wrong. Your test is formatted like this. So there are 25 different CUDA-generated problems, so I'm expecting to take anywhere from 45 minutes to an hour, depending on how fast you guys are. These cover all of the same topics that were on the 50-problem review guide that we had, and area between two curves. Then you've got 5 original problems, which are a little bit harder from me. So these are ones that are not computer-generated, but that are tailored in order to have as many of these 4 things as possible. So you're going to be looking at integration with inverse trigonometric functions combined with some other topic. So integration with partial fraction decomposition, improper fractions, or completing a square. And then you're going to have one long form word problem. These are technically, for next year, they'll be timed at 15 minutes. So I'm expecting them to take you a little bit longer, so around 30 minutes. So in total, for a student that is maybe a little bit slower, I'm expecting this to take a maximum of around 2.5 hours. So because this is long, you guys are going to have all of Friday, 2 weekends. So that first weekend before spring break, the weekend after spring break, all the week of spring break, and then I'm not taking this until the Wednesday when we come back. But please don't try to work on this on the Tuesday after we come back. Because it'll be a lot to do in one night if you try to do this in one sitting. So if I was you guys, I would try to break this up. Maybe do this on 3 different nights. That word problem is going to be integration and accumulation based, so that's really similar to what we did last class period with the APFRQ. I'm kind of basing it off that. So the math's going to be pretty much the same, even though the situation's slightly different. Any questions on what's coming up for the test? Okay, so then the rest of this is just review for it. So we're going to be looking at some compound integrals that we can solve using different techniques of integration. Just for reference, I've posted a bunch of different integration rules here. So our general form for integration is, if we integrate from a to b, I'll have, it's actually reversed. I'm going to go back and change this. Oops. F of b minus f of a. So when we integrate a derivative, we'll end up with the original function and then the upper bound minus lower bound. If we integrate any of our trig functions, we'll work backwards. So when I derive sine, I get cosine. So that means when I integrate cosine, I will get positive sine. Same thing for our exponential functions and logarithmic functions, so we can work backwards. If I integrate e to the x, I'll get e to the x plus c. I don't have this one on here, but if I integrate u prime over u, you'll get the natural log of u plus c. If I derive ln x, I get 1 over x dx. So that's the same rule backwards. So all of these integration rules are just the opposite of deriving something. Okay, we've also got our inverse trigonometric functions for sine, secant, and tangent. Okay, I've got someone messaging me, so I'm going to make sure that's not someone on screen. Okay. All right, so average value and area between two curves. I've also thrown all of our derivative rules here into a review packet that's posted on WeChat. So these are all of our derivative rules forward that we've had so far, I believe, just for reference. The black space that we have here is stuff that we will learn before the end of the year but haven't touched yet, so I've blacked it out because it's not on the test. Okay, so I'm going to start with the hardest one I've got today. I'll just kind of work on this step by step, calling on people as we go. So let me get my list one more time. I've got Here we go. Kyle, Abby, Nikita, and Andrew and Eric. Okay. So I'm going to start off with this one. Kyle, starting with you. What do you think our u would be if I tried to do a u substitution here?
5 plus x minus x squared.
Okay, u is 5 plus x minus x squared. And if that's true, what is u prime?
U prime would be 1 minus 2x.
Perfect. 1 minus 2x times dx. So what that means is I do have the right power here, negative 2x, but I don't have the constant that I would need for the top. So what I'm going to have to do is I'm going to have to rewrite this function so that we do have what we need. I need this top to be 1 minus 2x in order to integrate. So I'm going to set this whole function equal to, in order to change this to be 1 minus 2x, I'm going to first multiply this function by negative 2 in order to get the negative 2x. So this will be negative 2x, and then I'll have to pull out a negative 1/2. If I multiply by negative 2 and divide by negative 2, then I don't change the original problem. So this is still just x on top. Okay, then over root 5 plus x minus x squared. Then if I need this plus 1 as well, I can add 1 to the top, but in order to not change the original function, I also need to subtract 1. Okay, now because 3 over 5 plus 4 over 5 is the same thing as 7 over 5, so that's 3 plus 4 over 5. I can break apart a fraction as long as I have the same denominator if I'm adding or subtracting. So that means I can take this negative 1 that we have here and pull it out. So this will be minus, I'm going to throw our integral here just so I don't get confused. So I've got the negative 1/2 I was multiplying everything by, so if I distribute that, this will be minus a negative 1/2, a negative 1 that I had here. Oops, I've done that too many times. This was minus 1, so this is minus 1. Okay. Root 5 plus x minus x squared. Okay, I did a lot in that first step, so any questions on what we did here?
What, Mr. Brendan?
Yes.
Like, so we multiply negative 1/2, and then why would there like be another negative on the outside again?
So I'll do this again. So my goal is to get to this u prime, which is 1 minus 2x, but we only have an x right now on top. So what I'm going to do is, first I'm going to multiply by negative 2 to get the negative 2x that I need, right? But if I multiply by negative 2, I'll also have to divide by negative 2 so that I don't change the original problem. Does that make sense?
Yes.
Okay, so then I also need a plus 1 in order to match this. But again, I don't want to change the original problem, so if I add 1 to the top, I will also have to subtract 1 from the top. Does that make sense?
Oh, yes.
Okay, then I've just pulled this fraction apart. So because if I'm adding, I can pull this apart into two separate fractions. If I do, this minus 1 will become, I'm going to leave this inside the integral for now. I've pulled this apart. So minus 1 will become a minus 1 over the same denominator. But right now, I'm multiplying everything by negative 1/2 and taking the integral of everything. So if I want to split this apart, then I would have to distribute both the negative 1/2 and the integration sign to both of these terms. So that would be negative 1/2 times the integral of this term.
Okay.
Okay, that was a good question. There was a lot going on in that first step. Okay, I'm going to rewrite this negative 1/2 because that looks kind of sloppy with the negative right there on the line for my fraction. Okay, so this left side is pretty much done since we've got u on top and u to the negative 1/2 really on bottom. This is negative 1/2 integral of u prime over square root u, which I'll simplify as we go. This side, though, needs a bit more work. So for the right side, On top right now, I had a dx that I was multiplying by everything on top, so I could say this is dx and dx distributed. On top, I've got a power of x to the 0 power, which is 1/2 then 1/2 minus 1 of my power on bottom. If you are 1 less than half your power on bottom, that's our sign that this is an inverse trigonometric function. If the power on top in the numerator is 1 less than half, the power on bottom. Use inverse trig functions. So that's my clue that this should be an inverse trigonometric function somehow. So that means I'm looking for, since I've got a square root and I'm starting with a constant, this is likely an arcsine function, which our formula for arcsine would be something like this. The integral of du over square root of a squared minus u squared is equal to the arcsine of u over a plus c. So if I want this to look like this, we'll have to rewrite this a little bit. I need my u to be squared in order for this to work. So what I'm going to do is I'm going to try to rewrite this 5 plus x minus x squared as a perfect square. If we complete a square with this, then I'll be able to make this u squared, some function squared. So I'll show you how that looks. Right now we have 5 plus x minus x squared. I'm going to first pull out a negative 1 to make this easier on myself so that our leading coefficient is 1. So this is negative 1 times x squared minus x minus 5. And then we'll complete a square. If I complete a square, then x squared plus bx plus b over 2 squared. So if I take my middle term's coefficient, divide by 2 and square it, I will create what's called a perfect square. That means a perfect square will factor into x plus b over 2 squared. Okay, so that's my goal here. So if I take my middle coefficient, that's negative 1, divide by 2, that's negative 1/2, and square it, that's positive 1/4, then I will get a perfect square. Okay, so if this is my rule, I'm going to box this so I don't think it's part of my process. This is my rule. My next step would be negative 1 times x squared minus x plus 1/4. That's negative 1 divided by 2 squared is 1/4. But I don't want to change the original problem, so I'm also going to subtract 1/4. And then I had a minus 5 on the outside. Minus 5 is negative 20 over 4. Okay, any questions on what I did here for completing a square? Okay, so what that allows me to do, if I rewrite this again, is reduce this to x to the first power. So this will be, if I factor, x minus 1/2 squared is x squared minus x plus 1/4. And then negative 1/4 minus 20/4 is negative 21/4. Okay, if I redistribute my 1 back in, that'll change the sign of this. So this will become 21 over 4 positive minus x minus 1/2 squared is equal to everything that we had inside that square root. Okay, so I'm going to take this really quick and we'll copy and paste.
Wait, Mr. Brendan,
Yes.
why does the positive 1/4 and negative 1/4 unable to cancel with each other?
They can cancel. I'm actually forcing that term in because that allows me to create a perfect square. So that 1/4 and negative 1/4 wasn't there originally. I'm intentionally putting and adding a 1/4 here because this part, x squared minus x plus 1/4 is a perfect square. It gives me the same factors, the same 2 factors that I can multiply together to get this. As long as you're in this form, x squared plus bx plus b over 2 squared, you'll be able to factor into two of the same factors. So right now my b is -1. If you take your middle coefficient, so that's the number in front of your x term, divide by 2 and square it, then you'll create what's called a perfect square. That's a quadratic that factors into the same two factors. Okay.
Hello.
Hello.
Okay. Sorry.
That's okay. So we just got our perfect square from this one. Is everyone okay with the perfect square, or should I keep going? Abby, are you okay?
Oh, yes.
Okay, cool. So that 1/4 is there because I added it to make a perfect square, but because I don't want to change the original problem, I also had to subtract 1/4. So that gave us our perfect square here. Okay, so this part is the same thing as this part that we have up here. So I'm going to substitute. So let me make a picture really quick. And I'll paste that in. To our next slide. Lots of stuff to carry over. Okay, so I'm going to keep going. For our left side, we said this could be -1/2 times, if I substitute, u prime is 1 minus 2x, so that's 1 minus 2x is u prime on top, over the square root of u. And then if I substitute for the right side, this will be a negative times a negative is a positive, so this is plus 1/2 times the integral of dx over the square root of, if I substitute the green for the green part, this will become 21/4 minus x minus 1/2 squared. Okay, once again, we do have a formula here that we can use. The integral of du over the square root of a squared minus u squared is equal to the arc sine of u over a plus c. So I'm going to make that substitution for the right side. Keep the right side here in yellow for a while. Since I already have a u that we substituted for, I'm going to rewrite this in terms of, I'll say w, so I'm just picking another letter. So if w is my u for this formula, then w would be x minus 1/2. My a squared would be 21/4, so that means a would be equal to the square root of 21/4, which is root 21/2. W prime would be dx. Okay, so if I make those substitutions for the right side, I will end up with this. 1/2 times the integral of w prime over root a squared minus w squared. On the left side, I'll stick the white. This negative 1/2 u prime over root u is the same thing as negative 1/2 times the integral of u to the negative 1/2 power. That's the square root that's on the bottom of a fraction. Negative means it's on the bottom of a fraction. 1/2 means it's square root times u prime. So now I can integrate this white part with power rule. And I can integrate this yellow part with our inverse trigonometric rule. Okay, so let me jump to the next person on the list. I've done Abby and Kyle so far, so let's go Nikita. Nikita, if I integrate u to the negative 1/2 power u prime, what will happen?
It's going to be the second. So it's gonna be u to the negative 3/2.
Okay, so we are integrating, not deriving. So this time we'll need to add 1 to the power and divide by the new power.
Oh, I meant u to the 1/2.
Okay, u to the 1/2 power.
Yeah, u to the 1/2 times 2. Oh
Perfect.
no, actually,
You're right.
yeah,
So-
times 2.
Okay, if I divide by 1/2, if I'm dividing by a fraction, you can flip and multiply. So dividing by 1/2 is the same thing as multiplying by 2/1. This will become 2/1 times u to the 1/2 power. Okay, plus c, and then in yellow, plus, okay, that's everyone that was here on Skype at the start, so I'm going to jump over to Zoom. Let's go Andrew first. So Nikita or Nini? Nikita, can you disable your microphone, please? Thanks. Okay, so Andrew, for this yellow part, if I integrate using our inverse trig function, what will happen? Andrew, are you there?
Hello.
Hey. If we integrate this yellow part, what will happen?
So it will be arc sine
Arc sine.
plus is W over A plus C.
Plus c, perfect. Okay, so now we just need to substitute. Anywhere I see a u, we can replace it with u, and anywhere I see a w, we can replace it with w, anywhere I see an a, we can replace it with a. So our last step is the substitutions. I'm going to try to write way over here so that we can do the substitution in 2 steps with what little space we have left. So this is, in white, I've got negative 1/2 times 2, the 2's will cancel, so that leaves with negative u to the 1/2 power, or negative, my u was 5 plus x minus x squared. 5 plus x minus x squared to the 1/2 power, which I will simplify to a square root in my last step. And then in yellow, we've got plus 1/2 times the arc sine, 1/2 times the arc sine of my w was x minus 1/2, divided by my a, which is the square root of 21/2. Root 21/2. Again, if I'm dividing by a fraction, I can flip and multiply, so I'm going to do that for my last step, plus c. Now this plus c and plus c, I multiplied that c by 1/2 is still a constant c. I added another c to it, it is still a constant c. So because we don't know what the constant is, you can combine all of those constants into c. Okay, so my final answer will look like this. This 1/2 is a square root, so this is negative root 5 plus x minus x squared. And then in yellow, plus 1/2 times the arc sine of 2x minus 1 over the square root of 21 plus c. Okay, any questions on what we did here? There's kind of a lot to that one. I was trying to pick a problem that has kind of everything in it. So the next ones will be a little bit easier. But if you can do this one, you can do just about anything that's on the test. Okay, let's try another. So I'm starting with Eric for this one. Eric, what do you think my u is for the first part?
100 plus x to the 10th power.
Okay, perfect. U is 100 plus x to the 10th power. If that's the case, then what is u prime?
10x to the 9th.
10x to the 9th power. Okay, I do have that here, x to the 9th power, but we don't have the right power for this x to the 4th. So what do I need to do first?
Is u 2 times u plus.
Right, so I've got 2u prime on top for this first part. Okay, so I'm going to break this apart into two separate fractions. Again, for Ninny who just showed up, I've got 5 over 7 plus 3 over 7 is the same thing as 5 plus 3 over 7, right? So as long as I've got the same denominator, we can break this apart into two separate fractions, which is what I'm going to do for this first step. I've got two different integrals here, really the integral of 20x to the 9th power over 100 plus x to the 10th, plus the integral of x to the 4th power over 100 plus x to the 10th. Okay, and as Eric was saying, I can split this 20x to the 9th power apart into 2 times u prime over u. Okay, so the left side is all solved. Okay, for the right side, I'm going to skip Ninny for the next turn in the order because she wasn't here for the first part. So let me go back to Kyle, and I'll come back to Ninny after this. So for Kyle, right now my numerator, the top part of this fraction, is 1/2 minus 1 of my largest power in the denominator. So I could say my numerator is 1 less than half the power of my denominator. What does that tell us?
I'm sorry, could you repeat?
My numerator is x to the 4th power. That is 1
Yes.
less than half of my bottom part. Half of 10 is 5, minus 1 is 4.
Oh, okay.
That's a clue that I need to use what type of function to solve this.
Wait. Tangent? Oh, like, one. Wait.
You're right. So special type of tangent function though. So this is an inverse tangent function or an arctangent function, you could say. Anytime you have a power that is 1 less than half your power on bottom, that's your clue that you're going to use an inverse function to solve these integrals. So either inverse sine, inverse secant, or inverse tangent. Okay, and you're right, this one's inverse tangent because we don't have a square root. Okay, so our formula for inverse tangent, I'm going to write over here really quick. Arctangent is the integral of du over a squared plus u squared is equal to 1 over a times the arctangent of u over a plus c. So I need this to look like this. Okay, I'm going to jump back to Ninny first. So Ninny, if this on the right side is an arctangent function, which part of this is a squared?
Mm, tangent? Oh, 100.
Okay, 100 is a.
100.
Perfect. 100 is a squared. That means a must be.
A must be 10.
A must be 10. Okay, awesome. What is my u squared, which I'm going to call w for now because we already have a u. So what's the function of this arctangent part that we are squaring? Okay, looking for this part. U squared will be w squared for us.
5x to the power of 5.
Close. My w squared is just going to be that whole term as is. So right now w squared is x to the 10th power. And then I think you're trying to reduce for me. So what would w be then if I take the square root of both sides? W should be x to what power?
To the 5th power.
5th power. Okay, awesome. And then the last thing we need for this is w prime. So w prime will be the derivative of x to the 5th. So what happens when I derive x to the 5th power?
5x to the 4th power.
Perfect. Okay, I actually didn't write my dx's earlier, so I'm going to do that really quick. This is dx and dx should be in both terms because I was multiplying the entire fraction by dx. That would distribute. Okay, so if I substitute now, I'm going to jump over to Kyle. So this is 2 times u prime over u still. This is plus the... I don't have a 5x to the 4th on top. I've just got x to the 4th. So what do I have to do?
So, so 20 over 100, so 1 over 5.
Okay, so I'm going to multiply by 1/5 and multiply by 5 will give me 5x to the 4th dx on top, which is w prime. Okay, so I'm going to make all my substitutions in this step, so I'm going to run out of space otherwise. This is w prime over a squared plus w squared. Okay, we are ready to integrate. Kyle, I'm going to stick with you because that was kind of a short turn. What happens when I integrate the left side?
So, is it starting from 2? Oh, so 2 ln? Yeah. Ln. U prime is...
Oh.
Oh.
Getting ahead of myself, sorry. 2 ln u. If I derive ln x, I get 1 over x times dx. So if I derive ln u, I'll get 1 over u times du, or 1 over u prime. Okay. Plus, how about this part?
Plus 1 over 5 times 1 over a.
Okay, what is a?
10.
1 over 10. Okay, times...
I think this is where we do the tangent thingy.
Yep, arctangent.
So, arctangent x to the power of 5 over 10.
X to the 5th over 10, perfect. Plus
C.
Plus c. Awesome. So I just need to... I think I'm actually going to leave this in general form for this step because I did for the left side. So you're right. But just for later reference, this is A, and W. Okay, so I'm going to substitute in, and then we've got our final answer. So my final answer will be 2 times the natural log of u, which was 100 plus x to the 10th power. 100 plus x to the 10th power, plus 1/5 times 1/10 is 1 over 50. Arctangent of w, x to the 5th, over a, 10, plus c. Okay, any questions on this one? Okay. Let's see. I'm gonna erase this line so I already did that substitution in the next line, and that makes a little bit more sense to me, I think. Just so I don't have the dangling part over here. Okay. So then I've got two more, I think. We are back to Abby. Abby, what is my u?
4 minus x4.
4 minus x to the 4th power, perfect. U prime then is what?
4x to the 3rd power.
Really close, really, really close.
Oh, and negative 4x.
Right, negative 4x cubed. Okay, so I will need to break this apart into two separate fractions. I do have a positive 4x cubed, so what will my first fraction be?
Negative.
Negative times the integral of negative 4x cubed over root 4 minus x to the 4th power. Okay, that's fine. Now, if I break this apart first, so I had 4x cubed plus 2x over root 4 minus x to the 4th, and then multiply by the negatives, then you can see this one should not be negative, right?
Yes.
Okay, cool. So that's our first step. And I've got my u and u prime, so we've got everything we need to substitute for the easier left side. And now we need to work for the right side. I'm going to jump over to Nikita. Nikita, what tells us that this should be an inverse trigonometric function?
The fact that the x has a power.
Okay, it is the power. Right now my power on top is 1, my power on bottom is 4. If I divide 4 by 2, I get 2, and then subtract 1, I get 1. If you can divide the bottom power by 2 and subtract 1 and get your top power, that's our clue that we need to use an inverse trigonometric function. Inverse trigonometric functions always have 1 less than half the power on bottom. Okay, so for this one, our inverse trigonometric function, is this going to be an arcsine, arcsecant, or arctangent, do you think?
I think it's gonna be arcsecant.
So
Because is it an arcsine or arcsecant? Because it has a square root.
okay, you're right, those two have square roots, and the difference is arcsecant will have a u on the outside as well, and it will start with the function and end with the constant. Sine always starts with the constant and ends with the function. So for this one, this will be an arcsine, which is the integral of du over root a squared minus u squared is equal to the arcsine of u over a plus c. Okay, so with that, what do you think our function would be? So for us, I'm going to call that w, since we already have a u. Actually, let's start with w squared. What is w squared?
Wait, so w squared is the entire function?
Looking at the entire function, but our whole function should be in this form. So if I want to rewrite it in this form, then what would the w squared be?
Oh, okay, so it would be. Wait, do we substitute our values into the u, or we just write it with u and a?
We're going to rewrite this using this format. However, because I already have a u, that's different. Instead of using u for this substitution, I'm going to use w. So that's just the next letter in the alphabet.
Okay, so then I guess it's gonna be 4x cubed
4x.
over
4x cubed would be the derivative of this whole part.
yeah, but it says like du over a squared and u squared, so
I
du
see.
is 4.
Okay, so
Yeah.
before we substitute for all of this, I'll rewrite this in terms of w if that makes it easier. So this is dw w squared and w over a. Okay, what is this w squared part first?
Oh, w squared is 16 minus
Looking at
x to the eighth.
okay, looking at this.
Sorry.
Um,
Sorry, it's gonna be 2x squared over x minus x to the fourth. I mean 4x squared.
Okay, I think we're getting ahead of ourselves. I just want to know this term. So what is this part for this fraction?
Negative x to the fourth.
Okay, so this part would just be x to the fourth for w squared, since I'm subtracting all of w squared. Okay, if w squared is x to the fourth, then what will w be equal to?
X squared.
X squared. What would w prime be equal to? What's the derivative of x squared?
2x.
2x dx, okay? And then if a squared is this first term, then what would a squared be?
2.
Okay, I think you've gone a step ahead. A is 2, but the a squared is that whole term, which is 4.
Oh, sorry.
You're okay, you're okay. So we're going to make that substitution. So my next line will be this. This whole integral is equal to negative integral of u prime over root u plus the integral of, this is w prime is 2x, w prime over a squared is already 4, so this is square root of a squared minus w squared. Okay, I'm going to rewrite this using one more step. Who's next in my order? I've got Andrew's next in the order. Okay, so Andrew,
Yes.
how can I rewrite this term on the left so that we can use power rule? Oh, Nikita, can you disable mic again? Thanks.
Power rule.
Yep, I want to rewrite this so that we can use power rule to integrate it. So this is u to what power?
U to negative 1.
Close, negative
1 over 2.
1 over 2, perfect. The 1 over 2 gives me a square root. The negative means it's on the bottom of a fraction. So if I want to rewrite this square root on the bottom of a fraction, that would be u to the negative 1 over 2 power. Okay, that's awesome. And then plus everything over here stays the same. The integral of w prime over root a squared minus w squared. And we are ready to integrate. Andrew, I'm going to stick with you for one more, I think. So what happens when I integrate this left side?
It will be negative 2u, negative 3,
Oh.
negative 2 over 3, u,
Uh,
negative.
Okay, we're going to add 1 to the power and divide by the new power. If I add 1 to negative 1/2, what will I be left with?
Oh, 1/2.
Positive 1/2.
Positive 1/2.
Okay, so this will be u to the 1/2 divided by 1/2, which is the same thing as...
Over 2.
language difference, I think. But if I'm dividing by 1/2, that'll be the same thing as multiplying by 2 over 1. Okay, then I've still got that negative on the outside from here. Okay, plus, how about this part?
Sine. Arc sine.
Arc sine. Sorry, arc sine of
W over A.
W over A plus C. Okay, I've combined my plus C's. You can do that because all of my plus C's are constants we don't know. Eventually you'll combine them. So you don't need to write plus C for all of your integrals. As long as you're adding, they're all going to end up adding together to get some constant we don't know. Okay, so we said if I'm dividing by 1/2, that's the same thing as multiplying by 2. So this is -2 times the square root of u, which is 4 minus x to the 4th power. Plus the arc sine, all I'm doing is I'm substituting, of w, that's x squared, over a, which is 2, plus c is our final answer. Any questions on this one? Okay. Last one for today. Starting with Eric. What's my first substitution?
What do you mean? X squared plus 2x plus
Okay, that means u prime is equal to what?
2x plus 2.
2x plus 2. Now that's not what I have on top. How could I rewrite this so that I get 2x plus 2?
No. 1 half u prime
Okay, I can do that. Then if you want to add 2, you'll also have to subtract 2. So plus 2 minus 2. So that I don't change the original problem. Okay, now if I want to break this apart, I can. So this will be 1/2 times the integral of 2x plus 2 over x squared plus 2x plus 10. Minus 1/2 times the integral of 2. So that was my minus 2 over x squared plus 2x plus 10. Now, because I was already multiplying by the 1/2 times everything that's on the inside, I did have to distribute that 1/2 into both of these integrals. This negative comes from the -2. Any questions on our split? Okay, I'm going to stick with Jin for our first part of our right side here as well, before we break. So I do have 1 less than half the power on top. That tells me this is an inverse trig function. Eric, what inverse trig function should this be? Cosine's the same as sine. I would have a square root on the bottom. Tangent. Okay, tangent's the only one that does not have a square root on bottom. So that gives me our formula. The integral of du over a squared plus u squared is equal to 1 over a times the arctangent of u over a plus c. Okay, so that means I do need to rewrite this. I'll need to complete a square with the bottom part in order to be able to get a u squared. Okay, I'm going to jump over to our top of the order for Skype, which is Kyle. So Kyle, I've got x squared plus 2x plus 10. X squared plus 2x plus 10. How can I rewrite this so that we can complete a square?
X squared plus 2x, so it's x plus x plus 2x plus
So one more time.
Plus 1.
Plus 1, perfect. So our trick here is for x squared plus bx, in order to create a perfect square, I would have to add b over 2 squared. In order to get a perfect square, that will give me x plus b over 2 squared for my factors. So I divide 2 by 2 to get 1, and then square it to get 1. Okay, but I don't want to change the original problems. If I'm adding 1, I also have to subtract 1. And then I've got the 10 I was adding earlier. Okay, this part, x squared plus 2x plus 1, will give me a perfect square. Okay, so how can I rewrite this with my perfect square? Yeah? Sorry.
X plus 1 squared?
X plus 1 squared. Okay, and then on the outside?
9. Plus 9.
Plus 9, perfect. Okay, so this bottom part of the fraction can be rewritten like this as a perfect square. Okay, so let me rewrite really quick. I've got 1 over 2 times the integral of u prime over u minus 1 over 2 times the integral of 2 over 9 plus x plus 1 squared. Okay, I did flip the order on that. If I'm adding, I can rewrite this in any order though, and the reason why I did that is so that I would match my formula, so you can see which one's a, which one's u a little bit easier. Okay, who's next in the order? I've got Abby.
Yes.
So Abby, what is a squared?
A squared is 9.
9, that means a is
3.
3. Okay, what is u squared?
U squared. X plus 1.
Okay, x plus 1 squared. That means u is what?
Square root of x plus 1.
If u squared is x plus 1 squared.
Oh, x plus 1, x
Okay,
plus 1,
then
sorry.
u is x plus 1. That's okay. And u prime is...
It's just dx.
Right. 1 times dx. Awesome. Okay, so on top I've got 2 right now. So I'm just going to move that 2 out to simplify. So this will be 1/2 times the integral of u prime over u minus, if I move that 2 out, this will be 2 times 1/2 is 1. So that's minus, oops, I should make these w's because I already have a u. Okay, I'm going to rewrite these. This is w squared, w, and w prime. So this will be w prime over a squared minus w squared. And we're ready to integrate. Who's next? I've got Nikita next. Nikita, if I integrate u prime over u, what will happen?
It's going to be natural logarithm of u.
Natural log of u, perfect. And if we integrate w prime over a squared minus w squared, what will happen?
It's going to be minus natural log of a squared minus w squared.
Not a natural log, no.
Oh no? Okay.
For a natural log, my power difference would have to be 1. Right now this is w prime, not w to the first power, so my power difference is actually 2. That's 1 less than half my power. I'm going to jump to Nini for help. Nini, what happens when I integrate this part?
Which
Nikita, can I get you to mute again? Thanks. Nini, what's going to happen for this part?
which part?
This one right here. If I integrate w prime over a squared minus w squared.
Um, over
Okay, 1 over a times okay, I think you're breaking up a little bit. If I integrate this, we've got our arctangent function. So this is going to be 1 over a times arctangent of what?
tangent.
Okay,
So it's what 1 over a.
okay, I'll have 1 over a, then I need one more thing on top.
And then tangent to the arctangent
Oh, I see, okay, 1 over a arctangent of what?
of w over a.
Perfect. Okay, 1 over a arctangent w over a plus c. So last thing we need, I'm going to substitute all of our variables in. So we need to substitute for u, substitute for a, substitute for w, and we're done. Okay, so what's our final answer? I've got 1/2 natural log of u. What is u?
U is is the u w or the u is the u?
So the reason why we pulled the w is because I didn't want to confuse it with the u. So this u is my original u.
Which is x squared plus 2x plus 10.
Okay, x squared plus 2x plus 10 minus 1 over a.
1 over 3 arctangent x plus 1 over 3 plus c.
Awesome. All right. Any questions on anything from today? Okay. So I've kept you guys for the full hour for the first time. So we'll break here. You don't have any new homework. However, I still need the partial fractions homework from some people and the word problems by midnight Friday. The test should be going out at some point tonight. My goal is 9 p.m. on WeChat and 11 p.m. on course sites. With everything we talked about earlier. So thank you very much. I will post an overview of the test again and the cheat sheet that we saw earlier to the WeChat as we break, and I will see you guys after the spring break.
Mr. Brandon?
Thank you.
Problem.
Thank you.
Okay, Kyle, you had a question?
Is the test on course sites multiple choice or we better
Uh,
answers?
It's free response. So
Oh, okay.
not multiple
Sorry.
choice. I have not posted to course sites yet. I've finished writing it, but I need to compile it into each of the forms. So I'm hoping I'll have that done by 9 p.m. and send that out to you guys through WeChat. And then at 11 p.m., hopefully my course site upload will be finished.
Oh, okay. Thank you.
No problem.
Have a good break.
Thanks, you
Good
too.
Thank
break.
you.
Goodbye.